Okay, what if we had to draw the Haworth structure of a ketose? What kind of steps would we take to do that? How to draw the Haworth of a ketose. So it's going to be pretty much the exact same procedure. We are going to start, let's start with a nice normal sized ketose. Remember, the ketose has the carbon oxygen double bond on carbon number 2. So we're looking at this. Oops, too many oxygens. And we're going to have our OH groups on the left side, the right side, the left side. And so before we turn this into a Haworth structure, I'm going to tell you that this is sorbose. And is this the D or the L sorbose? Remember where you need to look. 1 carbon up from the bottom, the OH group is on the left-hand side, so this is our L sorbose. So let's number the carbons in this chain just like we did for the aldose. 1, 2, 3, 4, 5, 6, and now we're ready to draw. We're going to turn it on its side, 90 degrees, clockwise, 90 degrees to the clockwise. Draw it like this. And again, I think it's easier if you just literally turn your paper to the side. So it's gonna help you get everything going in the right direction, because it's really important that you get the OH groups on carbons 3 and 4 and 5. You have to get them going in the right direction, otherwise you're going to draw the wrong structure. 1, 2, 3, 4, 5, 6. Those are 3, 4, and 5 are the most important carbons. The other carbons, carbon 2 and carbon 1 and carbon 6, remember that those don't really matter all that much. The chiral carbons are the only ones that matter. So we're going to get it onto its side, and then let's be consistent. Let's see what we did next up here. Okay, we went straight to the template. So for a ketose, the template of the cyclic structure is different. It's a 5-membered ring. So wow, that was a giant oxygen. 5-membered ring like this instead of a 6-membered ring. And it is still going to have these up and down vertical bonds through the ring, so we can kind of draw those in. And we are always going to have, so it's very similar to the aldose, we are always going to have carbon number 6 right here, CH2OH. That is our carbon number 6, which means this is carbon number 5. And carbon number 5's hydrogen is also always pointing down. So let's look back up at our aldoses at carbon number 5 with the CH2OH sticking up and the hydrogen sticking down. That's always something that we see. So let's continue numbering around the ring. This is going to be 4, this is going to be 3, this is going to be 2, which means carbon number 1 is going to be out here, hanging out somewhere out here on the ring. And we'll get to that guy. So let's take a look at how we need to orient carbon number 4. Carbon number 4, the OH is down, so we'll match that in our cyclic structure. And carbon number 3, the OH is up, so we'll match that as well. And so now we're moved on to carbon number 2. Now this, carbon number 2, is very similar to what we had at carbon number 1 for our aldoses. This carbon number 2 is our anomeric carbon. This is our anomeric. So it's this carbon that dictates whether this is going to be the alpha or the beta anomer. We have on this particular carbon, we're going to have an OH group, and we're also going to have carbon number 1, the CH2OH. So maybe the OH group is sticking down and the CH2OH is sticking up. That's carbon number 1 right there. That's one option. And the other option, we'll draw it over here. Draw in your straight lines. Put your CH2OH up there and your hydrogen right there. That's carbon number 6 and carbon number 5. And this right here, what you're looking at right now, that is the generic template for a ketose in the cyclic shape. They're always all going to look like that. As you go around the ring, carbon 4 and carbon 3, the position of the OH groups on those carbon atoms will depend on your straight chain structure. And then when you get over here to carbon number 1, the position of the stuff on there depends on if you're being asked to draw the alpha anomer or the beta anomer. There's always going to be an OH and there's going to be a CH2OH, and the direction that you point them depends on if you're drawing alpha or beta. So the first structure that we drew, because the OH group is down under the C with the fishies, this is alpha L sorbose. And in our other structure, the second structure we drew, because the OH group is up high in the sky with the birds, this is beta L sorbose.